All right, here we go. This one's a little bit nasty. I'm not going to lie. So let's start off slowly. When I identify my index is 2. So I'm very comfortable with dealing with my coefficient here of my radicand, and my coefficient of my radicand is 24. So I'm going to deal with this 24 first, and then I'm going to split this up. Now, what perfect square factor of 24? Sorry, let me repeat that. What is a perfect square factor of 24? And that is 4. That's the highest one. So it's 4 times 6. So I've taken care of 24. Now the next thing I'm going to do is I'm going to take care of this x to the power of 3. Now it's important to play along and follow along that my index is 2. So I'm going to choose to write x to the power of 3 as x squared times x, with the full intention that x squared is a perfect square. I can take the square root of x squared. Now, y to the power of 5, we would write this as, I'm going to decompose y to the power of 5. And since my index is 2, I'm going to split up my exponent y to the power of 5 to y to the power of 4 times y to the power of 1. So I'm just going to underline all those things that I can take the square root of. And I'm going to reorganize them and put them all together. Everything that I cannot take further square roots of, I'm going to put those together. So now I'm just going to say this is the square root of 4 times x squared times y to the power of 4 times the square root of 6xy. So essentially everything that I could take the square root of, I put under one radical. Everything that is sort of non-square rootable, I left over in this radical on the right. Now I'm going to evaluate the square root of 4. So, and if I want, I can split this up further, but I feel like this next step seems a lot of unnecessary work, right? So I'm going to do it once, but we're going to try to push us further. So I could rewrite this as, I'm just going to copy this down. So the square root of 4 times x squared times y to the power of 4 is the square root of 4 times the square root of x squared times the square root of y to the power of 4 times the square root of 6xy. And by the way, you and I both know, we've established long ago that this is all the parts that are left over that are non-square rootable. So if I just simply evaluate the expression on the left, square root of 4 is 2, square root of x squared is x, square root of y to the power of 4 is y, and there we have it. All right, I'm done, but I'm going to take maybe a quick look, and I'm going to start at this step, this yellow step here. I'm going to try to cut out all of this work here, if so, right? If it's possible in our minds. So the square root of 4x squared y to the power of 4, the reason why I have all of these together is that I've organized them in a way that I can take the square root of everything. Now, on the right-hand side, I carried on my work, but I can just simply write 2xy squared, that is, take the square root of them all in one go, and I will end up with the same answer, depending on which way you like, and it's your choice. All right. Really big idea, though, is that you have to split up your radicand into things or into exponents that are divisible by the index of your radical. Now, that's a mouthful, and it's really hard to explain, but hopefully later on we'll come by and get it. So I'm looking here, I'm going to maybe take this one. This one's not very nice. Now, by the way, my index is 4. So what I have to do is I have to break up this n to the power of 8 so that the exponent is divisible by 4. And lucky, just lucky for me, that n to the power of 8, you can take the 4th root of it. So I'm going to maybe just simply do this for ease of my mind. Now, that was kind of very sloppy on my hand, but I already know that I can take the 4th root of n to the power of 8. So, now, what is the 4th root? How can I break down this? Now, this is quite hard. So, I'm going to say 2. Now, 2 to the power of 4 is equal to 16. 2 to the power of 5 is 32. 2 to the power of 6 is 64. Now, 2 to the power of 7 is 128. Now, this is bad news for us. So let me restart this question over again. What I'm going to do is simply this. I am going to rewrite all of the things that I can take the cubed root or the 4th root of. And what I get is 16 times 8, which is 128, times n to the power of 8. Now notice I have established that I can take the 4th root of n to the power 8, and I can take the 4th root of 16. So what I'm going to do as a small step is I'm just going to reorganize my factors as 16 times n to the power of 8 times 8. And I'm going to split up this radical. I'm just going to rewrite it. So here we are. I'm going to break this up now as I'm missing my index 4th there. The 4th root of 16 n to the power of 8 times the 4th root of 8. Now, what is the 4th root of 8? I have no idea. So that's an irrational number. But the 4th root of 16 is 2. The 4th root of 8 is n squared. And that's my final answer. All right. I hope that this will come together very shortly for you. I know that it can be a little bit of a challenge. So if you have any questions, feel free to reach out. Maybe I will do one more example in the next video, but we'll save that for the next video.